Hi one and all, MaffsGuru here, and so delighted to see you for this our video on using Pythagorean his theorem. Now what do you mean his? Well, I'm not too sure. Rumour has it might actually not be Pythagoras' theorem. What do you mean you don't know? Why? No, seriously, I did a video. It's awesome. Oh, look, I'll just pause for a bit. Play the little best bit. The bit that maybe just sort of gets you to watch the next video. So I'm just going to stop now. You're a bit of a nutter. You're wrong, dude. You're so wrong. Now, obviously, for anybody who starts a religion to be told they're wrong, not necessarily a great thing. But if you were going to tell someone you were wrong, you'd probably choose the best place to do it, wouldn't you? I mean, the last place you would choose to do it would be on a boat. Yeah, and unfortunately, Hippasus may well have been clever, but he wasn't that clever because, allegedly, whilst on this boat, Hippasus turned around and went, "Yo, Pythag, mate." No, way too much of that. But you see, did you watch the rest of the video? No? Well, then there's a link in the description below. Now, while you're here, if you haven't already, and you're watching it through YouTube, do me a favour. Would you subscribe? There's a little doohickey thing in the corner there. Subscribers would make me feel so much better, really, because then I'd probably hope I've got more than 7 people in Hull watching me. Hey, Hull, if you are watching. Now, what were we dealing with? That last video was talking about Pythagoras' theorem, which is actually, in essence, really, really simple. That just introduced it. Now, what are we going to do this lesson? We are going to use it as it is normal above. The learning is being highlighted now. Realistically speaking, it's not very difficult. We just want to use it today to try and find missing sides, because that's what the Pythagoras' theorem is all about, being able to find missing sides, or more importantly, to prove whether a triangle is right-angled or not. Now, I'm not going to go back into that type of stuff because, we already did a recap. There was a snippet of me a moment ago. But what Pythag came up with was this idea that c squared equals a squared plus b squared. Now, in the United Kingdom, if you're watching this, I know we do it a squared equals b squared plus c squared. So much more sensible. Don't tell anyone I said that out loud. But the idea was that if you had a triangle that was right angle, so long as this side here was the letter on its own. So in Australia, c squared equals a squared plus b squared. So when I say the letter on its own, this side here is my hypotenuse. If in the United Kingdom you're using a squared equals b squared plus c squared, then you would use a as your hypotenuse. And what it said was the value of c squared, which was an area, was actually equal to a squared plus b squared. And again, by that, we mean the area of a box that had the length of A, B, and C. Now, lots of people do this in lots of different ways, okay? Sometimes, when I've taught it, people have done it by the squares. They actually draw the squares around the triangles. It's freaking awesome. But I'm just going to use it the boring algebra way. So what do I mean by that? Well, let's just draw a triangle. There, hello. That's let's say that's 5. Let's say that's 12. And let's put that down as a question mark. Well, actually, I'm not going to put a question mark because they're really hard to write. So let's call it, I don't know, that age-old unknown x. Now, I'm trying to find x. It's a right-angled triangle. I've identified it's a right-angled triangle because of the right angle. The right angle is pointing to the corner that's hypotenuse. And so I know that c squared is equal to a squared plus b squared. So always write the formula down first. Then I'm going to substitute. And in my lessons I go, yes, I'll do that again. What do I mean by formula? Substitute, solve. So here is my formula. Now I'm going to substitute. I'm going to take the values that are on my triangle and substitute them into my equation. So I get x squared is equal to 12 squared plus 5 squared. Now, solve. Well, I can't solve yet because I'm going to do another for simplifying. So we've got x squared, can't simplify that. 12 squared I know is 144. Now, those of you who don't know why, when you square a number, you're multiplying it by itself. So 12 squared is 12 times 12 plus 5 squared, which is 25. So x squared, I'm going to do another for simplify, because 144 plus 25 is 169. Okay, I can't do any more simplifying. I'm now going to solve. Because I want x on its own, I'm going to move that square to the other side. I'm going to make it the square root of 169. Now, for those of you who are interested, I should really write a plus or minus in front of there because there are actually always two values of a square root that will give me 169. But because this lesson is only for year 8, year 9, we'll just skip that for a moment. And I happen to know, using a calculator or just my brain, that x works out to be 13. Now, lots of people say to me, well, that's a lot of working out, MaffsGuru. Do I have to do that for every question? My advice is, oh yes, because these questions are worth a number of marks normally, and I know most exams will give you 1 mark for writing the formula, 1 mark for substituting correctly, and at least 1 mark for that line there as an answer. So 3 marks. If you don't write your working out, chances are you've lost all your marks. If you get your answer wrong, you are stuffed. So that's one way to find a missing side. Now, as I say here, the example I've just given above is called a Pythagorean triple. And again, from the previous video, we came up with a number of triangles that are called Pythagorean triples. So 3, 4, 5 was one of them. 5, 12, 13 was another one. And I believe 9, 40, and 41 is the third one. Now, there are lots and lots of these things. A Pythagorean triple is basically a right angle triangle where all the sides are whole numbers. So at this moment in time, we were dealing with nice numbers of 3, 4, 5, 5, 12, 13, 9, 40, 41. But unfortunately, not all numbers are actually going to be nice to us. So let's just make up an example here. Let's say 5 and 9 and x. All right? That's definitely not a Pythagorean triple, I can promise you that. So, same thing as we did before. I'm going to write my formula of c squared equals a squared plus b squared. Thank you very much, examiner. There's my 1 mark. Tick, even if I don't know how to do the question, I've got a mark. Substitute in the values, x squared is equal to 9 squared plus 5 squared. Okay, so there was my f. There's one of my s, and then do another s, which is simplify. And I've got x squared is equal 81, because 9 squared is 9 times 9, plus 5 squared, which is 25. Now that's for simplify, which gives me x squared is equal to 106. Now I'm going to tell you now, there is no square number that gives me 106. So to solve, I'm now going to write that as the square root of 106. Now, I could grab my calculator and try and work out what that is. Now, my calculator is way, way, way complicated. A lot more complicated than yours. So, I am just going to pause this video, not that you'll know that, and I'm just going to work it out on my otherwise known as phone. Thank you so much, Samsung and Apple. What would we do now without you? We have pretty much everything I could ever need. So, I'm going to do the square root of 106 and press enter. Now my calculator gives me this. X is equal to 0.295630141. That's what it shows me, but the chances are it's going to go on to infinity and beyond. Hi Buzz, how you doing? My favourite character. I love Buzz. I think he's awesome. Now the problem is we're not going to want to write this number over and over again. It is too long. So we could round to 2 decimal places. We've done that probably before in our course. So rounding out to 2 decimal places give me 10.30. And I'm going to write 2dp in brackets just so everyone knows I've rounded it. But the problem is that's not my actual answer. And what if, for example, this was only one part of a question? What if I then had to go on and use that answer in another part, and another part, and another part? Well, the problem with rounding to decimal places is that we start losing parts of our answer. In fact, it's not the answer we got. We knew for that question there that x was equal to the square root of 106. If I was to go and take, what was it, 10.2956, if I was to take 10.2956 and square it, I'm telling you now, I do not get 106. I get slightly less than 106. So wouldn't it be great if we had a number system or a way of writing answers that didn't need to be done to 2 decimal places or 3 decimal places? Hey! Well, if you've read above me already, yes, there is. It's called Surds. And here are some examples of Surds. Root 2. Root 3, root 5, root 7, root 11, root 13. Hello, they are all surds. I know. So if I was to put all of those into my calculator, I'd get decimal numbers that go on and on and on and on and on. But apparently, this Surds system allows us to leave our numbers with square root signs in it. I mean, that's freaking awesome. We can even have things like 2 root 3 and 4 root 7. Now, we have to be careful that we're not going to be tricked, because maths is a big fat trick, if you remember. Because sometimes, yes, square numbers and surds are here to trick us. Now, you'll notice there were certain numbers I missed out. So, for example, the square root of 9. Now, if I in an exam left my answer as the square root of 9, I'd probably lose marks because I'm not thinking about the mathematics. Because we know the square root of 9 is actually 3. It's really plus or minus 3. But again, depending on what level you're watching this at, will depend on whether you put those plus or minuses in. So if I ever ended up with a question that gave me an answer, say I'd ended up with x squared equals 16, and I'd done a load of working out before that, and then I got x was equal to the square root of 16, then I would absolutely be expected to write my answer down as 4, not leave it as the root of 16. If, however, I got that x squared was equal to 17, and I wrote the square root of 17, well, because I know that 17 isn't a square number, then it's perfectly acceptable to leave it as root 17. But I know what you're asking. I can hear you now. You're saying, well, how do I know when to use surds? Well, funnily enough, the question will tell you. You just need to keep an eye of the wording in exam questions, or in fact any question. If the question says leave your answer in exact form or exact notation or write it as an exact number, that's effectively telling to you, hello, use a surd. Now, interestingly, as I say here, and I've just actually rubbed it out, or I've covered it over with a pen, square roots aren't the only things that can be expressed in exact form. For those of you who've done stuff with circles, you'll remember that we have a circle, generally with a radius, and there's all sorts of things we can find out with regards to circles. The most common one are the circumference, which is 2 pi r, and the area, which is pi r squared. So if I had a circle, that's a really bad circle. And by the way, if you can draw a perfect freehand circle, apparently it's one of the definitions of clinical insanity. I know, you are trying to find that pencil and paper now, aren't you, to draw a perfect freehand circle. You knock yourself out. Not literally, because knocking yourself out, you won't be able to watch the rest of this video. Anyway, say I had that as 6. Then I know that my circumference would be 2 times pi times the radius of 6. So my circumference would be 12 times pi. Now I could, if I wanted to, do 12 times 3.14159, but we know that pi goes on to infinity and beyond. No bad this time. So actually it makes no sense, because we're going to sort of shorten our answer by rounding it to decimal places. And in many cases, it's much, much easier just to write my answer as 12 pi. Likewise with area. Same triangle, it's a circle. Same circle, pi times my radius squared, which gives me 36 pi. Leaving it like that is an exact form. Now, many times, even if the question doesn't say to leave it in exact form, my advice to you is leave it in terms of pi and keep working it out and working it out and working it out until you get to your final answer. And if your final answer then says to do decimal places, you would then, using your calculator, do 36.3.14159 or whatever it is. Now remember, your calculator has a pi button, so you can do all of that for you and then go on to round it to 2 decimal places. I suppose the last part of this video, because there's not a huge amount you can do. I can show you lots of examples, but not necessarily going to show you anything that I haven't already shown you. So here's a tip and a trick. Firstly, I know it sounds stupid, but read the question. A lot of people see right angle triangles and just go mental and they go, yay, it's Pythagoras Theorem, and they work out a load of stuff that doesn't actually answer the question. And always work out where a right angle triangle is. Now, this question has been used from the Cambridge Essentials textbook, which is what I'm currently teaching from to my group. And I have to say, it's a freaking awesome resource. If you're not using it, grab a copy. There's so many awesome questions. But here's an example of a question that I've seen in exams that trips people up all the time. A 20 centimeter straw sits in a cylindrical glass as shown. So a cylindrical glass just means it's a cylinder that basically has straight edges. What length of straw sticks above the top of the glass? Round your answer to 2 decimal places. Okay, so first things first, it doesn't say to do it in exact. So I've got to round it to 2 decimal places. Hopefully my very poor calculator, otherwise known as a phone, will be able to help me with this. A 20 centimeter straw. Now, what do you notice about your diagram? Do you see 20 centimeters anywhere on that diagram? No. Well, what it's trying to say is that that whole length from the start of the straw to the end is 20 centimeters. What length of straw sticks above the top of the glass? It's actually just wanting the length of that little bit there. Now, when they give you 3D diagrams like that, I don't think they're very helpful. In fact, they're there to try and trick you. I'm going to redraw the diagram like this. So there is my straw. I know that total length there is 20. Yeah? This is the one I'm trying to find, x, this little bit here that sticks out. They've given me a height of the cylinder is 14 centimeters, and they've given me the radius, that there is 4 centimeters. Well, actually, because I'm dealing with Pythagoras theorem, I'm looking for right angle triangles, and there we go. I should go, okay, there's my right angle. So I actually have a right angle triangle that is 14 by 8. Do you see why it's 8? They're trying to trick you. They're using circles to try and mess with your head. This whole distance here is 8 centimeters. Right, so first things first, I'm going to find this value here, x. How do I do that? Right, well, we know that c squared equals a squared plus b squared. I'm going to move it up so that my rather large head doesn't get in the way. C, I don't know, it's x, so there's my there's my x, I don't know it, 14 squared plus 8 squared. So x squared is, right, well, loading up my calculator, what do I get for 14 squared? I get 14 times 14 gives me 196. Plus 8 squared, which is 64. I'm going to and again. So I'm going to simplify this by doing 196 plus 64 gives me 260. And so x gives me the square root of 260, which is, what is it? Come on, give me the square root of 260, old trusty phone. 260 gives me, ooh, that's disgusting, 16.1245154966, and I'm assuming it's going on. Now, I'm going to leave that as it is. In fact, I'm going to use the value on my calculator. Now, the reason being is I'm not going to round now. If I round this now, the chances are I could end up with what we call a calculation error or a rounding error. So what have we just found out? Well, we have found out that this length here on my diagram is 16.12, and it goes on. How am I going to use that to find x? Well, as it just so happens, we knew the length of that whole straw, drawing a diagram again, the length of that whole straw, if I was to lie it flat, was 20 centimeters. And I know the bit that's inside the cylinder is 16.1245 ... centimeters. So how am I going to find x? Quite simply, I'm going to say that x is equal to 20 minus 16.1245. And notice I keep putting those ... dots. That's perfectly acceptable in maths because it says I have not rounded my answer. There are still more numbers after this, but I'm not going to write them all out. So, firing up my calculator, I am going to do 20, take away that, which gives me 3.875484, and lots of values. And is that how I'm going to leave it? Nope. Did it say exact value? No, if you remember back to the question, it said do it to 2 decimal places. So, 3.88 centimeters is the section that sticks out. So I've actually done a number of examples here. I've done a few examples here around the theory just to explain to you why this works. Now, I know that there are some people out there who would just love me to do question after question after question. Much respect, I would love to, but unfortunately what that tends to show, and I know this sounds weird, is that I can do the questions. If I can show you why it works and how it works and the basic principles, then you go away and practice and practice and practice. Now, if you need to, send me an email, send me a message below and say, yo, a bit confused. How did you do that question? And I'll do what I can to answer, maybe in another video. But do you know what, ladies and gentlemen? I think that's the end of this one. As ever, it has been fabulous seeing you. I said at the beginning, maybe if you're still watching it, there's an opportunity for you to subscribe. If you would mind, there's that subscribe button for you over there. And otherwise, there's a video loading for you to watch next. It's been good. This is MaffsGuru signing out. I'll see you next time. Bye-bye.